Hi, good evening everyone. Welcome back to the session. We'll be doing problems, concepts and preparation strategy was already completed. Now we do problems regarding calculus maxima and minima. Maxima and minima. So the minimum value of the function x cube by 3 minus x occurs at. It was given ESC prelims 2017 as well as ISRO exam electrical engineering 2013. Please do remember everyone, most of ESC and ISRO questions are to be answered within 60 to 65 seconds only, because the average time to solve the problem is within 1 minute only, maximum 65 seconds. So we can also solve within less than 1 minute only, but I want to explain everything in detail. The given function, let it be f of x. So x cube by 3 minus x. Now do you know to find the local maxima and minima, because interval is not given, so we need to find local maxima and minima. First of all, you need to find first derivative as well as second derivative, because first we have to find the stationary point, I mean critical point, the point at which f dash x is 0 or f dash x infinity is called a critical point. So find the value of f dash of x, x cube derivative 3x square by 3, x square minus 1. So that is x square minus 1. Similarly, you can find f double dash x as well. So f double dash x equal to 2x. Critical point means what? The point at which either f dash x is 0 or f dash x infinity. F dash x cannot be infinity for any finite real value of x. So the other choice or the other hope to find the critical point is the point where f dash x is 0. To know the point where f dash x can be 0, simply equate f dash x value to 0. Then it becomes x square minus 1 equal to 0, so that x equal to plus minus 1, plus or minus 1. Now substitute x equal to plus 1 here in f double dash x. Then it becomes f double dash of 1. F double dash of 1 is 2 greater than 0. Remember that f double dash x at any particular stationary point, I mean critical point, is greater than 0, then the function will have minimum value at x equal to 1. Therefore, the function having minimum value at x equal to 1. The question is, minimum value occurs at which point? So answer problem completed. Anyhow, we need to do step by step for you. Now f of x has a local minimum at x equal to 1. Similarly, you can find f double dash x at another critical point as well. What is that another critical point? Minus 1. So f double dash of minus 1. F double dash of minus 1 equal to 2 into minus 1. 2 into minus 1, that is minus 2 less than 0. F double dash x at any critical point less than 0, then the function having a maximum value at x equal to f of x has maximum value at x equal to minus 1. Suppose you wish to know what is that maximum value at x equal to minus 1, then you have to substitute x equal to minus 1 in the given function. If the resulting answer less than 0, so in the given function means in f of x, when you take x equal to minus 1 in the given function, you will get required maximum value. Similarly, when you take x equal to plus 1 in the given function, we get required minimum value. But we were not asked to find what is maximum or what is minimum. We simply have to find at which point minimum occurs. Look at this problem was given. Gate instrumentation 2007. Gate instrumentation 2007. Now you observe the problem. For real value of x, the maximum value of e to the power of sin x upon e to the power of cos x is. So before going to find the maxima or minima of the given function, first of all, you people should know this result. Suppose f of x equal to a sin x plus b cos x plus c. Suppose f of x equal to a sin x plus b cos x plus c, then minimum value of f of x is c minus square root of a square plus b square. Maximum value of f of x is c plus square root of a square plus b square. Now I want to apply the same formula for the given function also. The given function, let it be f of x, e to the power of sin x upon e to the power of cos x, let it be f of x. We studied this formula in the lower classes, I mean 11th class or 12th class calculus. Now you observe. So take the given function, let it be f of x. What is that? E to the power of sin x upon e to the power of cos x. Tell me, e to the power of cos x, if it goes to the numerator, then it becomes e to the power of sin x minus cos x. Now you observe, this is in the form of f of x equal to a sin x. What is a value? 1. A sin x plus b cos x. What is b value? Minus 1. So this is a sin x plus b cos x plus c. What is c value? 0. C value 0. So f max equal to e to the power of a sin x, a value plus 1, b cos x, b value minus 1 plus c, c value 0. What is maximum value? C plus, c means 0, square root of a square plus b square. A means sin x coefficient, b means cos x coefficient. A square plus b square. So therefore the answer is e to the power of root 2. E to the power of root 2. What is f minimum? Actually we were asked f maximum only. So but anyhow let us find minimum also. F maximum value e to the power of root 2. We got that answer already. Anyhow, safe side we are finding this value as well. F minimum equal to e to the power of c minus square root of a square plus b square. What is c value? 0. C minus square root of a square plus b square. That is equal to e to the power of minus root 2. So remember, this is a standard result. Otherwise, it becomes very lengthy if you solve this problem as per the procedure. First of all, you have to assume this function as f of x and e power cos x. If it goes to the numerator, it becomes e power sin x minus e power cos x. For that function, first we need to find the critical points, followed by we have to find the second derivative. It consumes a lot of time. Doing like this, we can save the time. Read this question, everyone. Tell me, a rectangle has two of its corners. A rectangle has two of its corners. Look there. A rectangle has two of its corners on the x-axis. Rectangle, two corners of the rectangle will lie on the x-axis, and other two and other two corners and other two corners and other two corners on the parabola y equal to 12 minus x square. The largest area of the rectangle is dash. Try to understand the question properly. We have one rectangle, two corners of the rectangle will lie on the x-axis and other two corners of the rectangle will lie on the parabola y equal to 12 minus x square. Therefore, the largest area of the rectangle is, for example, first of all you observe rough diagram. This is y equal to x square. This is y equal to x square. Any function is multiplied by minus 1, then its mirror image y equal to minus x square will be mirror image of y equal to x square. Any function is multiplied by minus sign, we get its mirror image of original function. This is y equal to minus x square. But we want minus x square plus 12. Minus x square plus 12 means same minus x square parabola will be shifted up 12 units. Minus x square plus 12 means same minus x square parabola will be shifted up 12 units. Same minus x square plus 12 parabola will be shifted up 12 units. This. So now let us draw the correct diagram. That is only the correct diagram. So y equal to 12 minus x square parabola this is. So what they said, a rectangle, two of its corners on x-axis and other two corners on the parabola. Fine. A rectangle, two of its corners. What they said is a rectangle, two of its corners on the x-axis and other two corners on the parabola. Means these two. Other two corners will lie on the parabola. Rough sketch only. This is a rectangle, two of its corners on the x-axis like this, and these two corners. Two of its corners on x-axis and other two corners on the parabola y equal to 12 minus x square. Now you observe that carefully here. This is the area. Observe this. In the shaded area consists of two rectangles. This is the first rectangle and this is the second rectangle. So I want to assume the length of this rectangle, let it be y, breadth of the rectangle, let it be x. So x is breadth and y is length. Or you can assume x length, y breadth, no issues. I want to assume y is the length and x is the breadth. So therefore area of the rectangle is side into side, means x into y. This rectangle area xy, this rectangle area xy. Therefore total area xy plus xy, that should be 2xy. Let us continue this. Remember the diagram once again. So remember, let x be breadth and y be length. So area of the rectangle is 2xy. But y value given in the statement of the question. What is y value? That we were given already. 12 minus x square. Y value 12 minus x square. 12 minus x square. Substitute there. So area of the rectangle is 2xy. Y value 12 minus x square. So this is the area. I want to assume this area as f of x. So let f of x equal to 2x into 12, that would be 24x. 2x into x square, that is 2x cube. To find maxima and minima, first of all we have to find the critical points. To get the critical points, we need to find f dash x. F dash x equal to 24 into x derivative 1 minus 2 into x cube derivative 3x square, 2 into 3x square, that is 6x square. This is f dash x. Now let me find the critical points. Critical points means the point where f dash x equal to 0 or f dash x equal to infinity. F dash x cannot be infinity for any finite real value of x. Therefore, the other choice to get the critical point is f dash x must be equated to 0. If f dash x is equated to 0, we get 24 minus 6x square equal to 0. So 6 is the common factor. And it is 6 into 4 minus x square equal to 0. 6 cannot be 0. So other possibility, 4 minus x square equal to 0. 4 minus x square equal to 0. X square equal to 4, x equal to plus minus 2. X equal to plus or minus 2, but minus 2 will not be considered because we have already assumed that y is the length, x is the breadth. So if x is the breadth of the rectangle cannot be negative. That's why x equal to minus 2 is wrong. We need to consider x equal to plus 2 only. This is the critical point. Do you know maxima and minima occur at critical points only? Fortunately, we got one critical point and we were asked to find the maximum value of maximum area of the rectangle. Means they have already said the given rectangle will have the maximum area. Therefore, what is that maximum value of the area of the rectangle? But maxima and minima occur at critical points and we got only one critical point. Obviously, that maximum area of the rectangle will occur at this critical point only. To know what is that required maximum area, substitute this x value in the given area. What is the given area? This is the area of the rectangle 2xy, which is also written as 2x into 12 minus x square, which is also written as f of x equal to 24x minus 2x cube. So to get the required maximum, you can substitute x equal to 2 in this function. This is area of the rectangle only. Therefore, f max equal to, substitute the critical point in the given function. What is the given function? 24x minus 2x cube. 24x, x value 2 minus 2x cube. This is 48 minus 16. 48 minus 16, how much? That would be 32. Therefore, the maximum area of the rectangle is 32. Similar model problem was already given in the GATE, Electronics and Communication Engineering in 2015. Look at that. But little bit different because the previous one is a parabola, but here it is a ellipse. Look, the maximum area of the rectangle should be measured in square units. The maximum area of a rectangle whose vertices lie on the Are you sure? Now let us look at this. First you draw ellipse. This is x square plus 4y square equal to 1 ellipse. But the vertices of the rectangle you observe this. X-axis, y-axis. The maximum area of the rectangle whose vertices, this is rough sketch only, the vertices of the rectangle will lie on the ellipse. Vertices of the rectangle will lie on the ellipse. Now you observe this. This is the area inside that rectangle. That is x square plus 4y square equal to 1. You observe this is the rectangle whose vertices lie on the ellipse. Inside the big rectangle, please observe, inside the big rectangle there are 4 subrectangles and all are symmetrical. How do you say that all are symmetrical? We have even powers of x as well as even powers of y. Whenever the given function contains even powers of x as well as even powers of y, it is symmetrical about x-axis as well as y-axis. Therefore, it is symmetrical about x-axis as well as y-axis. That's why all 4 rectangles are inside a big rectangle. We have 4 subrectangles, all are symmetrical, all will occupy the same area. So therefore, let x be the length and y be the breadth. Let x be the length and y be the breadth. Let x and y be the length and breadth. The length and breadth of a rectangle. So area of this subrectangle is length into breadth, that is x into y. Area of 4 rectangles is xy plus xy plus xy plus xy, 4xy. Let x and y be the length and breadth of a rectangle respectively. So area of the rectangle, I mean big rectangle, that is 4xy. This is also similar to the previous model question, but one thing, first of all, here y is there, so I want to write this y value in terms of x. I want to write y value in terms of x. What is the given ellipse equation? Given ellipse equation, x square plus 4y square equal to 1. So from this, 4y square equal to 1 minus x square. 4y square equal to 1 minus x square. So y square equal to 1 minus x square by 4. So substitute, but we just need y value. Y equal to square root of 1 minus x square by 4. Y equal to square root of 1 minus x square by 4. Square root of 1 minus x square by 4 means 2. Substitute this. This is equal to 4x y value square root of 1 minus x square by 2. Now here 2 1s, 2 2s. Now here take this 2x inside the square root. 2x if it goes inside the square root becomes 4x square. So therefore I want to assume this area as f of x. Assume area as f of x. So f of x equal to 2x. If it goes inside the square root, 4x square. So 2x, 4x square into 1, that is 4x square. 4x square into x square, that is 4x to the power of 4. This is the maximum, this is the area of the rectangle. This rectangle area we need to maximize. Now this under root function is there, no? That is 4x square minus 4x to the power of 4. Let it be f of x. Because to find the critical points, instead of taking the square root of 4x square minus 4x to the power of 4, or do one thing, instead of assuming this as f of x, this is area only. Just for the sake of our convenience, that under root function, actually if you want you can assume this entire function as f of x, no issues. But if it contains square root, calculation is somewhat lengthy. So that's why to get the critical points, this under root function is there, that is 4x square minus 4x to the power of 4, let it be f of x. Then there will be no change in the critical points. Even you assume that under root function as f of x, 4x square minus 4x to the power of 4. So to find the critical points, we have to find f dash x as well as f double dash x. First to calculate f dash x. If required, later we find f double dash x. So f dash x equal to 4 into 2x, 8x, minus x to the power of 4 derivative 4x cube into 4, that is 16x cube. Critical point means the point at which f dash x is 0 or f dash x infinity. F dash x cannot be infinity for any finite real value of x. So the other choice is f dash x can be 0 only. So from this, what is the common factor? 8x is the common factor. So take out 8x as a common factor. If I take out 8x as common, then it becomes 1 minus 2x square equal to 0. 8x into 1, 8x into 2x square, that is 16x cube. So this equal to 8 cannot be 0. The other choice is x equal to 0. 1 minus 2x square equal to 0, 1 equal to 2x square, x equal to plus minus 1 by root 2. These are the critical points. But you remember, in this statement of the problem, we have clearly assumed x is the length, y is the breadth. So length of the rectangle cannot be 0. If length of the rectangle is 0, then area should be 0. Then nothing can be solved. Moreover, length of the rectangle cannot be negative. That's why minus 1 by root 2 has been eliminated. So the one and only one point is this. This is a critical point. See, if you get two critical points, at which critical point it has either a maximum value or minimum value, that we need to check by finding f double dash x. F double dash x at any critical point less than 0, it has maximum value at that point. F double dash x at any critical point greater than 0, it will have minimum at that critical point. But fortunately, we got only one critical point. In this statement of the problem, it was clearly mentioned the given function will have a maximum value. So what is that maximum value? We all know maxima and minima occur at critical points only. Fortunately, we got only one critical point. Obviously, this maximum value occurs at this critical point. To know what is that maximum value occurs at that critical point, simply substitute this critical point in the given function. you will get required maximum area. Therefore, the maximum area of the rectangle, if you want to know, simply substitute your critical point in this area. So what is that? 4x square, and what is x value? 1 by root 2 whole square minus 4x to the power of 4, x value 1 by root 2 whole to the power of 4. Problem completed. Now you observe 1 by root 2 whole square, that is 1 by 2, minus 4 into 1 by root 2 whole power 4, that is 1 by 4. So 4 by 2, 2, 4 by 4, 1, 2 minus 1, 1. So answer is 1. The maximum area of the rectangle is 1. These types of questions we can expect both for GATE as well as ESE, or these types of questions can also be expected even in ISRO exam as well. So please remember, maximum area of the rectangle, or what is the maximum volume of the rectangular box, such that whose top is open. These types of questions practically they will ask in the exam point of view. It was given 2022 Civil Engineering, GATE Civil Engineering 2022. Read the problem once again. It is MSQ, multiple select question. So how many options correct? We need to identify. Let maximum of A comma B denote the maximum of two real numbers A and B. Which of the following statement or statements are true about the function f of x equal to maximum of 3 minus x as well as x minus 1? Do you know f of x also denoted by y? F of x means this is y equal to 3 minus x, y equal to x minus 1. First let us draw the diagram, after that we will check out the options. Roughly y equal to 3 minus x, and what is other curve? Y equal to 3 minus x, and another curve is y equal to x minus 1. Draw the diagram and please be careful. X-axis as well as y-axis. Now remember, to know the curve where it touches x-axis, substitute y equal to 0. Then you will get x value, means you will get the curve where it touches x-axis. To know this curve where it touches x-axis, put y equal to 0, 3 minus x equal to 0, x equal to 3. Means this line will touch x-axis at 3. To know the curve where it touches y-axis, put x equal to 0. If I take x equal to 0, we get y equal to 3. Means this line will touch x-axis at 3, y-axis at 3. So please draw one straight line such that it touches x-axis at 3 and y-axis at 3. This line touches x-axis at 3 as well as y-axis at 3. Now look at this line. To know the line where it touches x-axis, put y equal to 0, x minus 1 equal to 0, x equal to 1. This line will touch x-axis at 1. To know the line where it touches y-axis, put x equal to 0. What is y value? Minus 1. Means this line will touch x-axis at plus 1 and y-axis at minus 1. Let us draw one straight line that touches x-axis at plus 1 and y-axis at minus 1. A straight line touches x-axis at plus 1. A straight line touches x-axis at plus 1 and y-axis at minus 1. X-axis at plus 1 and y-axis at minus 1. Now Observe the diagram. This is y equal to x minus 1 line. This is y equal to 3 minus x line. Both curves intersecting at this particular point. Both curves intersecting at this particular point. To know what is this particular point, first of all, you have to solve this curve equation and this curve equation, then you will get xy coordinates of intersection point. What are those two curves? Y equal to x minus 1 and y equal to 3 minus x. Look. Y equal to 3 minus x and y equal to x minus 1. These two curves are intersecting. To know the intersection point, you simply solve these two curves equations. Both curves left sides are same. So right hand sides are also same. So 3 minus x, x minus 1 equal to 3 minus x. Minus x will go left side, minus 3 will go that side. 2x minus 1 will go right side, 3 plus 1, 4. So 2x equal to 4, therefore x equal to 2. If I take x equal to 2, what is y value? 2 minus 1, 1. If I take x equal to 2, y value 1. At x equal to 2, y equal to 1. Means these two curves intersecting at the point 2, 1. These two curves intersecting at the point 2, 1. Now let us draw the correct diagram once again. Everyone should be very careful because you observe if y equal to maximum of 3 minus x and x minus 1, this is x equal to 2 line. Don't get confused. I will draw the diagram once again. So have a look at the diagram. Now I want to draw the diagram once again. Here I will draw the diagram again because I don't want to draw. Simply I want to draw the diagram in this manner. Look there. Maximum of 3 minus x and x minus 1. Please be careful. Here this is x equal to 2, right? So x less than 2, which is maximum. This is 3 minus x curve, this is x minus 1 curve. In the region of x less than 2, this is x equal to 2, x less than 2 means this side, x greater than 2 means that side. In the region of x less than 2, which is maximum, means 3 minus x is maximum, or x minus 1 is maximum. In the region x less than 2, look there, x less than 2. Tell me some number which is less than 2, 1.5. So x value 1.5. 3 minus 1.5. 3 minus 1.5, 1.5. 1.5 minus 1, 0.5. So in the region x less than 2, in these two which is maximum? 3 minus x. If you want, you can check another x value also. X less than 2, I want to take x equal to 1. 3 minus 1, 2, 1 minus 1, 0. Which is bigger value? 3 minus x is the bigger value. So please do remember, in the region x less than 2, 3 minus x is the bigger value. In the region, this is x equal to 2 line. In the region x less than 2, 3 minus x is the value. This is x equal to 2. In the region x equal to 2, 3 minus x line is the maximum value. In the region x less than 2, 3 minus x. 3 minus x is the maximum value. In the region x less than 2. What is this? This is x less than this is x equal to 2 line. Rough sketch only. That is x equal to 2 line. Now, x greater than 2. This is x equal to 2 line. X greater than 2 means what? This side. X greater than 2. Tell me some number which is bigger than 2. Some number that is bigger than 2, 2.5. X value 2.5. 3 minus 2.5, 0.5. 2.5 minus 1, 1.5. Which is bigger? X minus 1 is bigger. So in the region x greater than 2, means this is x equal to 2 line, x greater than 2 means this side. In the region x less than 2, x minus 1 is the bigger value. Means in the region x greater than 2, in the region x greater than 2, this is the maximum value. Means this is the diagram. So therefore, in the region x greater than 2, in the region x greater than 2, this is the maximum value. So once again check. This is the diagram, rough sketch only. This is x equal to 2. So it will extend like this. Now look at the options. This is y equal to 3 minus x. This is y equal to x minus 1. Look at the diagram and what is option A? Problem completed. Directly we can tick options A. What is option A? F of x is continuous on its domain. F of x means the newly drawn diagram. F of x is the newly drawn diagram like this. It is a continuous function on its domain. So the drawn curve is a continuous curve on its domain. So option A is the right answer. What is option B? It has a local minimum at x equal to 2. Look there. You observe this. This is the curve. What is this? This is the smallest height of the curve from x-axis. Therefore, this is the local minimum. These are maxima, we don't know because it will go up to infinity like this. Somewhere it may have maximum value. So it has local minimum at x equal to 2. So option B, because this is the smallest height of the curve from x-axis, that is the local minimum at x equal to 2. It has a local maximum at x equal to 2. That this is not the maximum, this is the minimum value. This is the smallest height of the curve from x-axis, so minimum at 2. Maximum at 2 is wrong. Next option D is wrong. What is option D? It is a differentiable on its domain. Do you know? This is not a differentiable on its domain. Any curve that has a sharp edge at a sharp corners, as we discussed in the concept, at all sharp edges, at all sharp corners, function will not be differentiable. Therefore, f of x is not differentiable at x equal to 2. Therefore, option D is wrong. Only from the diagram we get complete picture about all options. If you want, you can define the function, but it is not required. This problem related to global maxima and minima given in the GATE Electronics and Communication Engineering 2021. What is the question? The function f of x equal to 8 log x to the base e minus x square plus 3 attains its minimum over the interval 1 comma e. What they are asking is, this function will have minimum. Suppose you are given certain interval. If you are asked to find minimum, that meant for you need to find global minimum only. If you are given certain interval, simply you are asked to find only maximum, you need to find only global maximum. Interval given, that problem is related to global maxima, global minima. Now, take the given function and remember the procedure that we discussed regarding global maxima and minima. F of x equal to 8 log x to the base e 8 log x to the base e, that is 8 ln x minus x square plus 3. That was defined in which interval? 1 comma e. Small e means 2.718. First of all, what is the procedure we discussed already? First we need to find the critical points of the function, means the points at which f dash x is either 0 or undefined, that is called critical point. But one thing, all critical points must lie inside this interval only. Any critical point that you come across lying outside the given interval will not be taken into consideration. Find f dash x. 8 into ln x, derivative 1 by x minus x square derivative minus 2x. Take LCM, then it is 8 minus 2x square. 8 minus 2x square LCM is x. 8 minus 2x square by x. Now I wish to find f double dash x as well. So from this, f double derivative of x equal to 1 by x derivative minus 1 by x square. Minus 1 by x square into 8, that is minus 8 by x square, minus 8 upon x square, minus 2x derivative minus 2. So what are the critical points? Critical points means the points at which f dash x should be 0 or infinity. Do you know, if I take x equal to 0 here, 8 minus 0, 8, 8 by 0, infinity. So therefore, f dash x infinity at x equal to 0, therefore x equal to 0 is a critical point. Don't worry, it will not be considered. Reason, this critical point doesn't lie inside that interval, so it will not be taken into consideration. Let me write first. Next, what are the points where f dash x can be 0? Simply numerator is equated to 0. That is 8 minus 2x square equal to 0. 8 equal to 2x square. So 2x square, x square equal to 4, x equal to plus minus 2, plus or minus 2. One root plus 2, another root minus 2. These are the critical points. But do you know, among all these critical points, how many critical points lying inside the interval matters? Rest of the critical points should not be taken into consideration. X equal to 0 lies outside that interval, minus 2 lies outside that interval, not required. That's why I said find the interior critical points of the function. Interior critical point means your critical points must lie inside the given interval. So now let us find local maxima and local minima. Means f double dash x at any critical point less than 0, then it has local maximum at that critical point. F double dash x at any critical point greater than 0, it will have local minima at that critical point. So that's why I wish to find f double dash x at the critical point 2. F double derivative of x at x equal to 2 will now be minus 8 by 2 square. Minus 8 by 2 square means minus 8 by 4 minus 2. That is minus 8 by 4 minus 2 minus 2. That is minus 4. Means less than 0. F double dash x at any critical point less than 0, it will have local maximum at x equal to 2. I'll write here. F of x has local maximum at x equal to 2. Suppose you wish to know, actually this is not required, because f double dash x less than 0 at any critical point less than 0, it will have local maxima. But read the question, minimum over the interval. That means we need global minima only. Global minima means what? f of a, f of b. A means what? One endpoint of the interval 1, b means another endpoint of the interval e, and f of a, f of b and all local minima. That is the required. Among all these, smallest is global minima. That's why local maxima not required. It is not required according to the constraint of the question, but anyhow I am showing the complete detailed solution, but for exam point of view it is not required. As soon as you get f double dash x less than 0, then you need not touch that. Not required also, no need to find f of 2. Anyhow, I am just finding for the explanation of detailed solution, but for exam point of view not at all required. Take x equal to 2, then it becomes 8 times of ln 2 minus 2 square 4 plus 3. So can you please tell me what is its value? Tell me what is its value. Anyone? Can you please tell me what is its value? 8 ln 2. You can find, otherwise I can find directly from the calculator also. Any response? Okay, I am finding myself directly from the calculator. 8 into ln 2. Calculator 8 times of ln 2. This is 8 ln 2 is 5.545 minus, let me check this value, minus x square. So this is only 4, minus x square means minus 4, minus x square means minus 4, minus 2 square minus 4, minus 4 plus 3 minus 1. So you have to substitute here f of 2 equal to 8 ln 2 minus 2 square minus 4 plus 3 minus 4 plus 3 minus 1. So that is 5.8 ln 2. So you can write this 5.545 minus 1 . So this is a 4.545, whatever it is, roughly you can verify and write that value. And similarly, you have to find f of x value at endpoints. Find f of a and f of b, means f of x value at endpoints of the curve. F of x value at endpoints of the curve, that is f, one endpoint of the curve is 1. So f of 1 equal to 8 into ln 1. What is the given function? Given function is 8 log x minus x square plus 3. 8 log x minus x square plus 3. 8 log x minus x square plus 3. So ln 1 is 0. ln 1 is 0. So this is 2. This is 4.545 something. Similarly, find f of e as well. So f of e equal to 8 times of ln e minus e square plus 3. So ln e is 1, 8 into 1 8, 8 plus 3 11, 11 minus e square. 11 minus c square. Could you please tell me what is its value? What is its value? E square. .61 roughly. This is 2, this is 4 point something, therefore the smallest value is 2. The smallest value is 2 and smallest value occurs at 1. Smallest value is 2 and the smallest value occurs at x equal to 1. Because we can write like this, because we were asked to write, look there, what you were asked, the smallest value. Minimum means what? Global minimum equal to. Global minimum equal to, this is the formula, smallest value of f of a. A means one endpoint of the interval, f of b another endpoint of the interval. Next, all local minima, but we did not get any local minima, we got local maxima only, so that's why we need not write that. This is equal to, what is the smallest value of f of 1 and f of e? 2. And that smallest value occurs at which point? Answer already completed, detailed solution I am giving. Smallest value occurs at 1 and smallest value 2, but we were asked smallest value occurs at which point? Occurs at x equal to 1. Now, you look at this question similar to the previous one only. This is also related to global maxima, global minima, because we were given the interval. Any maxima and minima problem related to interval is given, that must be related to global maxima, global minima. Let, I mean the given function f of x, which is already given, no need to assume, let 2x cube minus 3x square minus 12x plus 5. So find the critical points of the function 2x cube minus 3x square minus 12x plus 5, interval minus 2 comma 4. So find f dash x. F dash x equal to 2 into 3x square, that is 6x square minus 3 into 2x, 6x minus 12. Find f double dash x as well in order to find the critical, in order to find local maxima and minima. So f double derivative of x, 6 into x square, that is 12x minus 6. Now, critical point means the point at which f dash x is 0 or f dash x infinity. F dash x cannot be infinity for any finite real value of x. So the other choice to get the critical point is the point where f dash x can be 0. So f dash x can be 0 is 6x square minus 6x minus 12 equal to 0. So 6 is the common factor. If I take out 6 as a common factor, it becomes x square minus x minus 2. 6 cannot be 0. So other choice is x square minus x minus 2 equal to 0. What are the roots of x square minus x minus 2? Sir, 2 comma minus 1 I think. So these are the critical points. But these two critical points fortunately lying inside the given interval. Now you have to find f double dash x at each and every critical point. f double dash of 2. F double dash of 2 equal to 12 into 2, 24, 24 minus 6, 18 greater than 0 implies local minima at x equal to 2. Find f double dash x at another critical point minus 1. So f double dash x at minus 1, that is 12 into minus 1, minus 12 minus 6, minus 18 less than 0. Means local maxima at x equal to minus 1. Now let us find f of x. You need to find f of a and f of b. A comma b are endpoints and all local maxima and local minima. So first let us find. I will find local maxima. Means you have to find f of x because the local maxima at minus 1. So find f of x at minus 1, f of x at minus 1. F of x at minus 1, that is f of minus 1 equal to 2 minus 1 whole cube, minus 1 into 2, minus 2, minus 3 into minus 1 whole square, minus 5, minus 12 into minus 1, plus 12, plus 5, that is 17 minus 5, 12. What is this? This is the local maximum. Next, find out f of x at x equal to 2 as well. 2 cube, 8, 8 into 2, 16. Next, 3 into 2 square, 12, minus 12, minus 12 into 2, minus 24, plus 5. This is minus 36, minus 30 plus 10, minus 20, minus 20 plus 5, minus 15. This is local minimum. And then we need to find f of a and f of b. A means one endpoint of the interval, b means another endpoint of the interval, means f of minus 2. F of minus 2 equal to minus 2 whole cube, minus 8 into 2, minus 16, minus 2 whole square, 4, 4 into minus 3, minus 12, plus 24 plus 5. Please verify. Minus 12 into minus 2, minus 24 plus 5. So this is 24, this is minus 16, minus 16, minus 18, minus 28, minus 28 plus 4, plus 24, minus 28 plus 24, 5 minus 4, that is 1, 29, 29 minus 28. Next, f of 4, find the value of f of 4, 4 cube, 64 into 2, 128. 4 square, 16 into 3, 48. Minus 12 into 4, minus 48 plus 5. Now you observe 128, 80, 80 minus 48. 80 minus 48, that is 32. 32 plus 5, 37. Among all these, see here, global maximum means what? F of a comma f of b and all maximum. Largest value means global maximum. Largest value means global maximum. Global maximum means what? Largest value of f of a means one endpoint of the interval, f of b means another point of the interval. Next, all local maximum values are f of minus 1 only. Among all these, biggest value is global maximum. Biggest value among all these, biggest value is G max, global maximum. F of minus 2, 1, f of 4, 37, f of minus 1, 12. So among all values of f of minus 1, f of minus 1, f of minus 2, f of 4. Among all these, the biggest value is 37, means f of 4. That 37 is the global maximum. 37 is the global maximum. In the similar manner, you can find the global minimum as well. Global minimum means what? F of A, comma f of B. A means one endpoint of the interval, B means another endpoint of the interval, and all local minimum values. Smallest value of f of A, f of B, and all local minimum values, that would be the global minimum value. So still we have few more problems we will discuss in the next session. Thank you one and all.